Welcome to another Explainer. Today, we're tackling an eternal culinary quest, the pursuit of the perfectly crispy, golden French fry. For generations, getting that perfect crunch meant submerging potatoes in a giant vat of boiling oil. But lately, a new contender has completely taken over our kitchen countertops, the air fryer. It promises all the crunch with just a fraction of the guilt. But what is actually happening to your food inside that little machine? Well, today we're setting the stage for a data-driven laboratory showdown. Based on an incredibly detailed study from the University of Reading, we're going to put these two methods head-to-head to see exactly what you gain and what you lose when you make the switch.
I love this quote from a popular food blog because it really hits the nail on the head regarding our emotional connection with food. We all crave that nostalgic, comforting aroma of roasting potatoes, right? And that satisfying crunch when you take a bite is just the best. The air fryer promises to deliver this exact magic completely effortlessly. But as we know, magic is usually just science we haven't quite explained yet. So we're going to pivot sharply away from our feelings about fries and dive right into the rigorous structural science of how that crisp and crunch actually materializes on a cellular level.
Here's our roadmap for today's showdown. We'll be looking at Section 1, the air fryer promise. Section 2, setting up the experiment. 3, the time and heat test. 4, fat, moisture, and crunch. 5, the microscopic taste test. And finally, Section 6, the final verdict. Let's get right into it.
Okay, Section 1, the air fryer promise. Let's dive into this.
So, what exactly are manufacturers claiming these countertop devices do? Well, despite the name, an air fryer doesn't actually fry anything in the traditional sense. Looking at this schematic, you can see it's essentially a highly efficient, compact convection oven. Right at the top, there's an electrical resistance heater and a really powerful fan. This whole setup forces a high-velocity circulation of hot air down and around the food. Now, to try and mimic traditional frying, a superfine mist of oil droplets is introduced into this hot air stream. It's basically attempting to recreate the extremely high heat transfer rates of a deep-fat fryer, but using air instead of liquid oil to dehydrate the potato surface and form a crust.
To put into perspective just how massive of a difference we're talking about, look at this comparison. In standard deep-fat frying, your potatoes are totally submerged in a 20-to-1 ratio of oil to potato. That is an absolute ocean of thermal energy. In contrast, the air frying process in our scientific study uses a microscopic 0.003 grams of oil per gram of potato. And that tiny coating sets up the central conflict of our showdown. Can hot air and a tiny mist of oil genuinely replicate being completely dunked in boiling fat?
Section 2, setting up the experiment. To find the truth, the researchers at the University of Reading knew they had to create a perfectly balanced test. This wasn't guesswork. It was a true apples-to-apples comparison. Both the deep fryer and the air fryer were set to the exact same temperature, 180 degrees Celsius. They used Maris Piper potatoes, all cut into identical 9 by 9 by 30 millimeter strips. But here is the most absolutely crucial control variable: the finish line. The food industry standard dictates that a perfect, ready-to-eat French fry has to hit a final moisture target of 38 to 45%. The researchers didn't just cook them for a set amount of time. They cooked both batches until they hit that precise moisture level.
Which brings us to Round 1. Section 3, the time and heat test. 9 minutes. That is literally all it takes for the deep fat fryer to rapidly boil away the water and reach that perfect industry standard 38 to 45% moisture level.
But the air fryer? It takes a massive 21 minutes to hit that exact same target. That's way more than double the time just to get the same level of dehydration. So, why the stark difference?
Now, what's really interesting about this chart is the temperature evolution inside the fry itself. Check out the gray line for the deep fat fryer. It just rockets upward. The researchers found that the heat flux, which is the rate of heat energy transfer, is 3.7 times greater in liquid oil than in hot air. So the deep-fried potato quickly reaches the boiling point of water and just blasts past it as the crust forms. But now look at the black line for the air fryer. It takes much longer to heat up, and then it completely stalls out, plateauing right around 100 degrees Celsius. The inside never gets any hotter than that. That thermodynamic bottleneck is exactly why you're waiting 21 minutes for your snack.
Moving on to Round 2, Section 4, Fat, Moisture, and Crunch.
All right, time to address the elephant in the room, the fat content. Notice the massive gap in fat absorption over time here.
The air fryer line at the bottom barely even registers, it just stays flat. But look at the deep fat frying line up top. See how it actually spikes right at the end of the cooking process? Science tells us that most of the oil absorption in traditional frying doesn't actually happen while the food is in the oil. It happens right as you pull it out. As the fry starts to cool down, the water vapor inside condenses. This creates a literal suction pressure gradient, basically a vacuum, that vigorously pulls the surface oil deep into the core of the fry. But since the air fryer only uses that tiny mist of oil, there's virtually nothing for that vacuum to suck in.
Which leads us to the final fat content numbers for the finished products. The deep-fried potatoes held 5.63 grams of fat per 100 grams of dry matter. The air-fried potatoes, just 1.12 grams. So the data absolutely confirms the manufacturer's promise. Air frying drastically slashes fat content by roughly 80%.
Let's move to Section 5, the microscopic taste test, and see how this builds into the final product.
Okay, how does all this fundamentally change the physical structure of the food? Let's zoom all the way down into the cellular anatomy. You're looking at potato cells magnified hundreds of times in a scanning electron microscope. Take a look at the bottom left, figure F. Look closely at the crust of that air-fried potato. Do you see those large, empty void spaces? Because the water evaporated so slowly and there was no oil to fill those gaps, the crust actually shrinks and collapses on itself as it cools down. Now look just above it, at figure C, the oil-fried crust. It is thick, it's rigid, and it's completely structurally supported by all that fat that got sucked into the empty spaces. And this structural difference brings us to an absolutely crucial concept: starch gelatinization. This is simply the hydration and swelling of starch grains until they totally fill the plant's cellular lumen, which creates that soft, mealy, fluffy texture we all love in the center of a good fry. Remember how the air fryer's internal temperature plateaued at 100 degrees while the deep fryer just kept getting hotter? Well, because the air fryer is operating at a significantly lower internal temperature, thermal data proves there's significantly less starch gelatinization happening in the core of an air-fried potato. The chemistry inside is completely altered.
And this brilliantly illustrates how those microscopic differences translate to human experience. The researchers brought in a highly trained sensory panel to conduct a rigorous texture and taste analysis. The results were black and white. Now, the panel did find the visual color and the initial crispness to be pretty similar, but that's where the similarities ended. The deep-fried potato had a distinct fried odor and a mouthfeel described as oily and floury. That's all that gelatinous starch talking. The air-fried potato, on the other hand, was repeatedly classified as having a jacket potato odor. Without the oil to lubricate the crust, and with way less starch gelatinization in the center, the panel described the air-fried mouthfeel as desiccated, basically dried out, and tough.
Finally, Section 6, the final verdict. Let's wrap this up.
So, the crucial point is bringing all this data together impartially, so you can understand the precise trade-offs of each appliance. Deep fat frying? It gives you a lightning-fast cooking time. The incredible heat flux results in high starch gelatinization, delivering that classic floury soft core and a super rigid oily crust. But you're absorbing a massive amount of fat. Air frying, on the flip side, is a much slower process. The lower internal thermal energy means less starch gelatinization, which yields a tougher, more desiccated, and collapsed skin that frankly tastes a bit more like a baked jacket potato. However, your reward is a massive 80% reduction in fat content.
Which brings us to the ultimate question, and honestly, it's one only you can answer for your own kitchen. Now that you're armed with the microscopic reality of exactly what's happening to your food, you have to weigh that culinary experience against the nutritional data. Is the sacrifice in fluffy starch gelatinization and that perfectly lubricated, floury mouthfeel worth an 80% drop in fat? We've laid out the hard science, but the choice of how you chase that perfect crunch is entirely up to you. Keep learning, keep experimenting, and we'll catch you in the next explainer.